Hi, and welcome to our final presentation for the Yarra Valley water placement. First, a bit about Yarra Valley Water. Yarra Valley Water are one of the three main water retailers within the metropolitan areas of Melbourne, supplying water to the northern and eastern suburbs, servicing over 680,000 clients daily. There are many services which must be tracked and modified within the network, such as residential, commercial, and special services. Water usage by Yarra Valley Water customers, including households and businesses, is recorded through flow meters which are positioned across the Yarra Valley Water network. The initial requirement of this project was to build a forecasting model that projects the bulk supply volume of water for each of the different billing periods on a monthly scale. A more accurate method of modelling the supply of water was needed to enable a reliable method of measuring non-revenue water and verifying all billing charges. Non-revenue water is any water that escapes the system unaccounted for, with the extra cost being covered by Yarra Valley Water. Some of the main areas of non-revenue water are leaks and theft within the system. Theft mainly occurs from hydrants that has not been accounted for. As non-revenue water can reach into the millions of litres a month, an accurate model to predict this supply can help in the efforts to reduce costs and lead to lower water consumption. The bulk forecasting model created uses a reductive calculation for non-revenue water, with bulk water minus metered and non-metered water giving a prediction for non-revenue water for each of the given billing periods. There was a previous placement at Yarra Valley Water in 2017. This RMIT group used a dynamic regression model, which first applies a linear regression model that results in autocorrelated errors. These error terms are then modelled using an ARIMA time series model. ARIMA is used because the differencing is applied to the data prior to running the regression. The previous group used this technique to forecast a daily model using 9 of the 12 bulk supply zones within the Yarra Valley Water network. This was used as a stepping stone for our project, expanding on the use of the bulk supply zones to utilise the non-revenue water at a total network level, and further forecasting into the future. The goals of this project were to create a model employing the total network level of Yarra Valley Water to forecast and verify invoices received by the company for at a monthly level looking to forecast an entire year or 12-month period. This was achieved by adopting the 2017 model to daily forecasting, followed by performance testing, reducing the model, and finally adding extra important parameters for then expanding to the monthly model.
The AIC and BIC performance testing have allowed us to obtain an initial reduced model containing only the most important parameters. From this, we were able to introduce new variables that influence the monthly model, such as the average temperature over the last 3 years. This has let us successfully obtain a model that can accurately predict and verify the non-revenue water costs received by Yarra Valley Water. Some variables, such as the previous day's rainfall, were removed from the model in the parameter tuning. Both the daily and monthly models provide adequate forecasting accuracy, both well above the yearly means methods used previously by Yarra Valley Water. The daily model achieved accuracy of around 4.5%, whereas the monthly model achieved accuracy hovering around 5.5% for all the testing periods used. This accuracy is high enough for these models to be implemented within the budgeting and forecasting process of the company. In addition to this, investigation into modelling over COVID periods will be required. While the total monthly modelling performance remained high, service-specific modelling, such as residential and non-residential supply, did not remain as accurate. This is in line with the shifting of supply needs moving into the post-COVID world, with many people opting to work from home. Moving forward with the model's future aspirations, the implementation of the model in a software such as Microsoft Power BI seems to be the next logical step to automate the model. This will allow majority of employees at Yarra Valley Water to access the model and to be able to input newly accessed data in order to verify future invoices of non-revenue water. This is extremely valuable for the company, as now all sectors at Yarra Valley Water will be able to make use of the model and not just the analytical team. In addition to this, further research into alternative methods such as artificial neural networks may be explored in the future to possibly improve the model's accuracy.